The internet and the World Wide Web are not the same thing. Though the distinction has become nearly invisible, the difference is crucial. One is like the electricity flowing through your walls, while the other is the light bulbs and appliances that make that electricity actually useful. The internet is infrastructure, a network of networks that allows computers to send packets of data to each other. Invented around the 70s, it was a marvel of engineering. Completely decentralized, able to route around damage, it connected universities and research labs across America, and eventually the world. By 1988, if you were at MIT, you could send an email to someone at Stanford. You could transfer a file using something called FTP. You could join text-based discussion groups about specific topics. But here's what you couldn't do. Browse. Explore. Follow your curiosity from one piece of information to another. The World Wide Web changed that. If the internet is the roads and infrastructure allowing us to move around, the World Wide Web is the addresses, signs, and maps that tell us where we can go and how to get there. Tim Berners-Lee envisioned something more profound than a network of computers. He envisioned a web that worked the way human minds work, making associations, jumping between ideas, connecting thoughts that seemed unrelated. A universal space where anyone could share knowledge and follow their curiosity wherever it led. The Internet's killer app. What began as a tool for scientists to share research became a revolution in how humanity thinks and communicates. The web didn't just link computers. It linked people, ideas, and cultures, reshaping everything from how we learn to how we love. In less than a generation, it turned the world into a single, living network of knowledge, one that we are still learning how to navigate. Part 1. Enquire within upon everything. Tim Berners-Lee was born in London in 1955, into a family where computers were dinner-table conversation. His parents had met at Manchester University while working on the Mark I, the world's first commercial stored program computer. Unlike earlier machines that had to be manually rewired or fed instructions on punched cards, the Mark I could store and run programs from memory. One afternoon, Tim came home from school to find his father working on a speech, surrounded by books about the brain. His father was searching for clues on how the human brain makes connections and how to get a computer to ever work the same way. After the conversation ended, the idea stayed with Tim. What if computers could connect information the way brains connect thoughts? Tim studied physics at Queen's College, Oxford, graduating in 1976. Physics taught him to look for simple rules that could describe complex systems. The kind of thinking that would later shape how he designed the web. A few elegant principles, properly applied, could govern everything from the behavior of atoms to the movement of galaxies. In 1980, he took a 6-month consulting contract at CERN, the European Organization for Nuclear Research, straddling the French-Swiss border near Geneva. He was hired to help replace the control system for 2 of the particle accelerators. But the accelerators weren't the only complex system at CERN. The place was organized chaos. Thousands of scientists from dozens of countries, speaking different languages, using incompatible computer systems. They came to run experiments on particle accelerators, then returned to their home institutions scattered across the globe. Information was constantly being created and constantly being lost. There was no central database, no organized documentation system. Knowledge existed in people's heads, in scattered notes, and systems that couldn't talk to each other. When scientists needed to share data, they often relied on SneakerNet, physically carrying floppy disks or tapes from one computer to another, walking them across the lab. So, in his spare time, Berners-Lee started writing a program. He called it Enquire, short for Inquire Within Upon Everything, a Victorian-era book he'd seen as a child in his parents' house, a compilation of household advice covering everything from how to remove clothing stains to tips on investing money, organized as a kind of printed Wikipedia. His version of Enquire let him create pages of information about people, projects, software modules, and link them together. Each page was a node. Each connection was a link. You'd look at a page about, say, a software module, and at the bottom would be numbered links. Made by, runs on, used by. Click on Made by, and you'd see the person who wrote it. The links worked both ways automatically. It was crude, but it captured something essential. Information wasn't just isolated facts. It was relationships, circles and arrows, things pointing to other things, a web of connections. When his contract ended, he gave the program to a systems manager and left. The floppy disk was eventually lost, but the idea wasn't. Back in England, he worked on intelligent printers, with software for graphics, fonts, and document formatting. Work that gave him deep experience in text processing and markup languages. He returned to CERN in 1984, this time as a fellow. By then, he'd been introduced to the Internet, a global network already connecting thousands of computers. He'd also been reading about hypertext, the term Ted Nelson had coined in the 1960s for linked, non-sequential text. The pieces were coming together, and Berners-Lee realized what was needed: hypertext that worked across the Internet. Links that could jump from one computer to another, anywhere in the world, seamlessly. And crucially, it had to be completely decentralized. No central control or database from one company or institution. Anyone could set up a server. Anyone could create a page. Anyone could link to anything. In March 1989, he wrote a paper titled Information Management, a proposal. He explained the problem and delivered a solution: a distributed hypertext system where every piece of information would have an address. Documents could link to other documents across different computers, and the system would work over existing networks. But the proposal sat on desks for months, with no formal response. For over a year, he heard nothing but silence. Then came a breakthrough. Ben Siegel, the internet evangelist at CERN, had mentioned that a new kind of personal computer called the Next had intriguing features that might help them. Berners-Lee asked his boss Mike Sendall if he could buy one. Sendall agreed, and then added with a twinkle in his eye, "Once you get the machine, why not try programming your hypertext thing on it?" The Next computer was Steve Jobs' ambitious project after being forced out of Apple in 1985. Jobs had created what he believed was the future of computing, a machine with a beautiful interface called Next Step. In October 1990, he started writing code. The Next development tools were perfect. He could create applications quickly, dragging and dropping interface elements into place. By mid-November, he had a working browser and editor. He called it World Wide Web. It captured what he was trying to create: a global, distributed, interconnected system where any information could link to any other information. You could click on links to follow them. You could create new pages. You could edit existing pages. Reading and writing were the same activity, seamlessly integrated. But a browser alone wasn't enough. He wrote a server too, software that would hold web pages and deliver them to browsers when requested. And he created 3 core technologies. First, HTTP, Hypertext Transfer Protocol, the language computers would use to request and deliver web pages. It had to be fast. Documents should appear instantly. Second, HTML, Hypertext Markup Language, the format for creating web pages, with simple tags and angle brackets, H1 for a heading, A for a link. The tags would describe what something was, not how it should look. Third, URI, Universal Resource Identifier. Every document would have a unique address, the protocol, like HTTP, the server name, and the path to the document. With a URI, you could point to anything, anywhere. We've come to know these as URLs, though Berners-Lee originally insisted on the more universal term. 3 simple technologies. Together, they made global hypertext possible. By Christmas Day 1990, it was working. Berners-Lee's Next machine was running both the browser and the server. He could create a web page, save it, view it, and click on links that jumped to other pages. He registered a name for his server, info.cern.ch. On it, he created the first web page, explaining what the World Wide Web was and how to use it. It was a moment of quiet triumph. But if the web was going to be useful, it needed to reach people on all kinds of computers, not just the handful of Next machines at CERN. By mid-1991, the web existed in usable form. There was a server, two browsers, and defined protocols. Now, they needed people to use it. On August 6, 1991, Berners-Lee released the web to the world. He posted an announcement to several internet news groups, explaining what the World Wide Web was and providing links to download the software, the browsers, and the HTTP server that anyone could install. The response was slow but steady. People downloaded the software, sent bug reports, and asked questions. Occasionally, someone would email to say they'd set up a server. Each time, Berners-Lee would add a link to it on info.cern.ch, a manually maintained list of all known web servers. By the end of 1991, there were perhaps a dozen web servers outside CERN. The web existed, but it was barely more than an experiment. The question now was whether anyone beyond a small group of enthusiasts would care. Part 2. Browser Wars. The answer came quickly. Traffic on info.cern.ch doubled every 3 to 4 months. In summer 1991, there were 10 to 100 hits per day. By summer 1992, 1,000. By summer 1993, 10,000. In May 1991, Paul Kunz arrived at CERN from California. He was a physicist at the Stanford Linear Accelerator Center, one of America's premier particle physics labs. Like Berners-Lee, Kunz was an early NeXT enthusiast and had come to CERN to work on some common NeXT programs. But what he discovered there would change everything. When Berners-Lee showed him the web, Kunz immediately grasped its potential. Here was a way to share research papers and documentation without worrying about incompatible systems or formats. When he returned to Stanford, he shared it with the librarian who oversaw the material the lab produced. It was a godsend for making SLAC's substantial catalog of documents available to physicists worldwide. Stanford started the first web server outside of CERN. Word spread through the physics community and beyond. Students at universities started building browsers. Helsinki University of Technology produced Urwise. At UC Berkeley, Payway created Viola. The web was spreading, but slowly. It also wasn't the only internet information system emerging. Gopher, developed at the University of Minnesota, presented users with menus instead of hypertext. Because menus were familiar, Gopher initially spread faster than the web. But when the university announced it would charge licensing fees for commercial use in 1993, companies abandoned Gopher overnight for fear that any technology built on it could later be subject to lawsuits or licensing demands. Everyone turned to Berners-Lee. Is CERN going to do the same thing with the web? He'd been trying for a year to get CERN to release the web's intellectual property rights, and now, in the fallout of the Gopher debacle, they finally agreed. On April 30th, 1993, CERN issued a signed declaration. Anyone could use the web protocol and code free of charge to create a server or browser, to give it away or sell it without any royalty or constraint. This decision saved the web. With the web now freely available and legally safe, development accelerated. At the National Center for Supercomputing Applications at the University of Illinois, a student named Mark Andreessen and a staff member named Eric Bina were creating a browser that would change everything. In 1993, they released Mosaic. Mosaic was different. It was easy to install. It worked on multiple platforms: Unix, Windows, Macintosh. And Andreessen treated it like a product. He was constantly on newsgroups, listening for features people wanted, fixing bugs, publishing new releases. He responded to user feedback like he was running customer relations. Mosaic spread rapidly. By mid-1993, the majority of people on the web were using it. But there was a problem. NCSA's public relations department pushed Mosaic aggressively. The media started portraying Mosaic as if it were equivalent to the web, with little mention of Berners-Lee or the underlying technology. In April 1994, Mark Andreessen left NCSA and joined with entrepreneur Jim Clark to found Mosaic Communications Corp. They hired away the core development team from the university, and set out to commercialize their browser. They soon renamed themselves Netscape. On August 9, 1995, only 16 months after the company was formed, Netscape went public. The stock was set to open at $28 a share, but demand pushed it to $71. By the close of trading, Netscape was worth $4.4 billion. The company had yet to show a profit. If the web hadn't yet gotten the public's full attention, this remarkable story put it on center stage. The message to the commercial world was clear. The web was big business. The gold rush was on. New companies rushed to stake their claim. Yahoo, started in 1994 as a directory of websites, was becoming the go-to starting point for millions of users. America Online, previously a walled garden offering only their own content, began integrating web access for its millions of subscribers. Microsoft, which had initially dismissed the internet, reversed course. Bill Gates assigned people to develop a browser and announced that his company was going to embrace and extend the internet. In certain quarters, this phrase had ominous overtones. Embrace meant starting off compatible with other web software. Extend meant adding features that would make other systems seem incompatible. Berners-Lee realized the web could splinter into various factions, some commercial, some academic, some free, some not. This would defeat the very purpose of the web, to be a single, universal, accessible hypertext medium for sharing information. Everything he had designed for was at risk. The Internet Engineering Task Force, the collaborative body responsible for Internet standards created, was moving too slowly. The philosophical debates were endless. The process cumbersome. A different model was needed. Part 3. Consortium. In February 1994, Berners-Lee met Michael Dertouzos, director of MIT's Laboratory for Computer Science, at a cafe in Zurich. Over lunch, they sketched out plans for a consortium, an organization that could help developers and companies reach consensus on how the web should operate. Berners-Lee insisted it be international, with bases in both Europe and the United States. Dertouzos, who had always championed transatlantic collaboration, agreed immediately. Shortly after, CERN hosted the first international WWW conference. About 350 people gathered, the largest meeting yet of web developers and users. For the first time, people who had been interacting only by email were meeting face-to-face. Demonstrations filled the halls. New ideas sparked in every session. The press would dub it the Woodstock of the web. The energy made one thing clear. The web community was ready for structure, but the right kind. Neutral, open, coordinating rather than controlling. But then came unexpected news. In December 1994, CERN announced it had unanimously approved construction of the Large Hadron Collider, a massive new particle accelerator, and the next leap in physics research. To afford it, CERN would impose stringent budget cuts. No program outside high-energy physics could be supported. That included web development and any involvement with the consortium. The decision clarified Berners-Lee's path. MIT had already offered to hire him as full-time staff and form the World Wide Web Consortium, also known as the W3C. He could have started a company instead, but that risked fragmenting the web into proprietary products. He could have pursued academia, but that seemed too narrow. Leading the consortium would let him remain neutral, preserve the web's fundamental nature, and ensure it evolved in the right direction. Berners-Lee and his family left their house in rural France with 16 cases and boxes. On December 14, 1994, the consortium held its first meeting at MIT. About 25 companies attended, united by a common concern. HTML was fragmenting as competing browsers added incompatible features. They agreed to develop recommendations, common protocols that anyone could use freely for any purpose, including commercial products. The consortium would be vendor neutral, providing a space for reaching consensus rather than controlling the web. Berners-Lee would serve as director. The principles were clear: openness, anyone can publish, no permission needed; decentralization, no central authority controls what exists; universality, anything can link to anything, crossing all boundaries; free protocols, no licensing fees, no proprietary control. Every technical decision was also philosophical. Decentralization wasn't just about scalability, it was about freedom. Open protocols weren't just about interoperability, they were about preventing monopolization. The balance was delicate, moving fast while staying open, innovating while standardizing, serving individual companies while protecting the whole community. But the foundation held, built on principles that mirrored the web of human connection itself that Tim Berners-Lee held so dear. Over the following years, the consortium grew to include hundreds of member organizations worldwide. It developed dozens of recommendations that became the foundation of the modern web, from XML and CSS to accessibility standards and privacy protocols. Epilogue. By 1998, the web had grown beyond anyone's early imaginings. Hundreds of millions of people were using it. Thousands of companies had built businesses on it. The consortium had produced dozens of recommendations, but growth brought new challenges. Concerns about pornography accessible to children led to calls for government censorship. Questions of privacy, security, and commercial control would continue to emerge as the web became woven into the fabric of daily life. Some things were lost along the way. The web had become primarily a medium for consuming information, not creating it. Berners-Lee's original vision, that reading and writing would be equally easy, that the web would be as much for collaboration as for publication, had been only partially realized. The browsers had won, editors had lost. But the foundation held. The web remained decentralized by design, open by default, universal in scope. No single company could own it. No single government could control it. It existed as a space, an information space, that humanity collectively inhabited and shaped. One person's vision, implemented in a few thousand lines of code, shared freely with the world, had reshaped human civilization. The work continues. The web is still being woven, link, by billions of people. We are the threads holding this world together. This was Weaving the Web by Tim Berners-Lee, first published in 1999. Thanks for listening.